Hello my friends, and welcome back to KrossUSA channel. Today we're taking an exclusive look inside some of the world's most sophisticated manufacturing facilities. Let's dive into the precision, power, and ingenuity behind today's manufacturing marvels. What you're witnessing here is one of the most elegant solutions in modern pipe manufacturing, the spiral welding process. This isn't your grandfather's pipe making technique. This is 21st century engineering at its finest. The magic begins with a continuous steel coil, typically ranging from 6 to 24 millimeters in thickness. Watch as this massive steel strip feeds into the forming station at a precisely controlled angle, usually between 30 to 80 degrees, depending on the desired pipe diameter. The beauty of this process lies in its continuous nature. Unlike traditional straight seam pipes that require multiple pieces, spiral pipes are formed from one continuous strip. Notice the sophisticated edge preparation system working ahead of the forming rolls. Those beveling machines are creating the perfect V-groove along both edges of the steel strip, ensuring optimal weld penetration. The precision here is remarkable. We're talking about tolerances measured in fractions of millimeters. Now here's where it gets really interesting. Those massive forming rolls you see, they're not just bending the steel. They're creating a helical shape with mathematical precision. The lead roll determines the pipe's diameter, while the side rolls control the spiral angle. Modern systems can produce pipes ranging from 16 inches to over 120 inches in diameter, with wall thicknesses up to 25 millimeters. The welding process itself is a masterpiece of automation. That's a submerged arc welding system you're seeing, operating at temperatures exceeding 6,000 degrees Fahrenheit. The inside weld is laid down first, followed immediately by the outside weld. The entire process maintains a consistent travel speed, typically between 0.5 to 6 meters per minute, depending on the pipe specifications. What makes this particularly impressive is the quality control happening in real time. Those sensors are continuously monitoring weld quality, pipe roundness, and dimensional accuracy. Any deviation triggers immediate adjustments, ensuring every pipe meets strict industry standards like API 5L or ASTM 252. The finished pipes emerging from this process can handle pressures up to 1,440 psi and are used in everything from water transmission systems to oil and gas pipelines. It's fascinating how this continuous process can produce pipes over 60 feet long with remarkable consistency and strength. Now let's step inside one of America's premier pipe manufacturing facilities, US Pipe Company, where tradition meets cutting-edge technology. What you're seeing here represents over a century of pipe-making expertise, combined with state-of-the-art automation. This facility specializes in ductile iron pipe production, and the process is absolutely fascinating. We're starting with molten iron at approximately 2,700 degrees Fahrenheit. That's hot enough to melt copper. The iron is carefully treated with magnesium to create the ductile properties that make these pipes incredibly strong yet flexible. Watch this centrifugal casting process. It's like watching controlled chaos become perfect order. The molten iron is poured into spinning molds, rotating at speeds up to 1,000 RPM. The centrifugal force distributes the metal evenly, creating pipes with superior density and strength. The precision of this process is remarkable. These molds are machined to tolerances of just a few thousandths of an inch. What sets US Pipe apart is their integrated manufacturing approach. See those robotic systems handling the pipes? They're part of an automated quality control system that inspects every single pipe for dimensional accuracy, surface quality, and structural integrity. Each pipe undergoes hydrostatic testing at pressures 50% higher than the rated working pressure. The coating process you're witnessing is equally impressive. That's a specially formulated cement mortar lining being applied centrifugally. This isn't just protection. It's engineered to provide smooth flow characteristics that actually improve over time as the pipe is used. The exterior gets a zinc coating followed by an asphaltic seal coat, a 3-layer protection system that can last over 100 years underground. The precision machining stations are where the magic of modern manufacturing really shines. Those CNC machines are cutting joints and preparing pipe ends with tolerances measured in thousandths of an inch. The push-on joint system you see being manufactured here creates leak-proof connections that can withstand ground movement and pressure variations. US Pipe's quality control is legendary in the industry. Every pipe is tested, measured, and certified. They're producing pipes that will carry water to millions of Americans for the next century. When you turn on your tap, there's a good chance the water traveled through pipes made right here using these advanced processes. The facility can produce pipes ranging from 3 inches to 64 inches in diameter, with lengths up to 20 feet. These aren't just pipes, they're engineered systems designed to withstand decades of service in challenging underground environments. Welcome to one of the most technologically advanced steel facilities in the Middle East, ArcelorMittal's Jubail plant in Saudi Arabia. What you're witnessing here is seamless tube manufacturing at its absolute finest, representing the pinnacle of metallurgical engineering. The process begins with solid steel billets, typically 6 to 12 inches in diameter, heated to a precise 2,200 degrees Fahrenheit in those walking beam furnaces. The temperature control here is critical. Too hot and the steel becomes difficult to work with. Too cold, and it won't flow properly through the piercing process. Now watch this incredible piercing operation. That's a rotary piercer, and what it's doing is essentially creating a hole through the center of a solid steel billet while it's red hot. The billet rotates while being pushed over a piercing mandrel at tremendous pressure. It's like watching steel being transformed from solid to hollow in a matter of seconds. The forces involved here are absolutely enormous. We're talking about pressures exceeding 1,000 tons. The elongation process is where the real magic happens. Those are pilgrim mills you're seeing, and they're stretching that pierced billet into lengths up to 130 feet while maintaining perfect roundness and wall thickness uniformity. The precision is astounding. Wall thickness variations are kept to within plus or minus 5% across the entire length of the tube. What makes ArcelorMittal's process special is their advanced process control system. Those infrared cameras and laser measuring devices are continuously monitoring temperature, dimensions, and surface quality. The entire process is controlled by sophisticated algorithms that make thousands of micro adjustments every minute. These sizing and finishing mills you see here are engineering marvels. They are capable of producing tubes ranging from 2 inches to 14 inches in outer diameter, with wall thicknesses from 0.2 inches to 2.5 inches. The surface finish achieved here meets the most demanding specifications for oil and gas applications. The heat treatment process is equally impressive. Those tubes are passing through precisely controlled cooling systems that can achieve specific mechanical properties. Some tubes are quenched and tempered to achieve yield strengths exceeding 80,000 psi, while others are normalized for optimal machinability. Now let's visit Bremen Machinery in Germany, where precision meets power in one of the most impressive demonstrations of plate rolling technology you'll ever see. They're using Heistler roll plate machines, considered the Rolls-Royce of plate bending equipment. What you're witnessing here is a 4-roll plate bending machine that represents over 150 years of German engineering excellence. This particular Heistler machine can handle plates up to 160 millimeters thick and 4 meters wide. To put that in perspective, we're talking about steel plates that weigh several tons being shaped with the precision of a watchmaker. The genius of this 4-roll design lies in its ability to create perfect circles and consistent curvature without the flat ends that plague 3-roll machines. Watch how those 4 independently controlled rolls work together. The top roll provides the main bending force, while the side rolls control the plate's entry and exit angle. The bottom roll acts as a support and final forming element. The hydraulic system powering this machine is absolutely massive, generating forces up to 2,000 tons. That's equivalent to the weight of about 400 elephants pressing down on the steel plate. But it's not just about raw power, it's about controlled power. The hydraulic cylinders can adjust pressure in increments so small they're measured in fractions of a PSI. What makes Heistler machines special is their CNC control system. That operator isn't just guessing at settings, the computer is calculating the exact roll positions needed based on the material properties, thickness, and desired radius. The system accounts for spring back, work hardening, and even temperature variations in the steel. Look at that plate positioning system. Those are numerical control axes that can position the plate with millimeter accuracy. The entire process is programmed, so once the parameters are set, the machine can reproduce identical parts with remarkable consistency. This is particularly important when you're making cylindrical sections for pressure vessels or wind tower segments, where fit-up tolerances are critical. The pre-bending operation you're seeing is crucial for eliminating flat spots. Those adjustable side rolls are creating a slight curvature at the plate ends before the main bending operation begins. This ensures that the finished cylinder has uniform curvature from end to end. The material handling system integrated with these machines is equally impressive. Those powered roller tables can handle plates weighing up to 50 tons, moving them into position with precision and safety. The entire system is designed around efficiency, minimizing handling time while maximizing accuracy. Bremen uses these machines to fabricate everything from massive storage tanks to components for offshore platforms. The quality standards they maintain are incredible. Roundness tolerances measured in millimeters on cylinders that are meters in diameter. They're producing components that will operate in some of the world's harshest environments, from Arctic oil fields to desert petrochemical plants. The versatility of these Heistler machines is remarkable. They can produce not just cylinders, but cones, elliptical shapes, and even complex multi-radius forms. The same machine that's rolling a simple cylinder today might be forming a complex transition piece for a wind turbine tower tomorrow. Quality control throughout this process involves continuous measurement and adjustment. Those digital readouts you see aren't just showing roll positions. They're providing real-time feedback on the curvature being achieved, allowing operators to make adjustments before completing the forming operation. Here's something truly special. The Abbend APK240, a vertical profile bending machine that's revolutionizing how we shape structural steel and complex profiles. This Turkish-engineered marvel represents the cutting edge of profile bending technology. What makes this machine unique is its vertical orientation and incredibly versatile bending capabilities. Unlike traditional horizontal benders, this vertical setup allows for much better control over complex shapes and eliminates many of the handling challenges associated with long, heavy profiles. The APK240 can handle profiles ranging from simple angles and channels to complex custom extrusions weighing up to 240 kilograms per meter. That's serious capacity. We're talking about bending structural beams that would require cranes to move manually. The machine's design allows it to bend profiles up to 400 millimeters in height, making it perfect for architectural and structural applications. Watch the precision of this 3-roll bending system. The upper roll is hydraulically driven and provides the main bending force, while the 2 lower rolls are precisely positioned to create the desired radius. What's remarkable is how smoothly the profile moves through the machine. There's no stuttering or hesitation, just continuous, controlled bending. The CNC control system is where this machine really shines. The operator can program complex bending sequences, including multiple radii in a single piece. See how the machine automatically adjusts roll positions as the profile passes through? That's real-time calculation of bending forces based on the material properties and desired curvature. One of the most impressive features is the machine's ability to handle both the easy way and hard way bending of profiles. Easy way bending curves the profile around its minor axis, while hard way bending, much more challenging, curves it around the major axis. This Abbend machine handles both with equal precision. The material handling system integrated with the APK240 is engineering at its finest. Those powered in-feed and out-feed tables can handle profiles up to 12 meters long, automatically feeding material into the bending zone at precisely controlled speeds. The entire system is synchronized to prevent any binding or distortion of the profile during bending. Quality control features include continuous monitoring of bending angle and radius. The machine can detect variations in material properties and automatically compensate, ensuring consistent results even when working with different heat lots of steel. This is particularly important in architectural applications, where visual consistency is critical. The versatility of this machine is truly impressive. It can bend everything from simple handrails to complex curved roof trusses. In the hands of skilled operators, it can create shapes that would be impossible or prohibitively expensive using traditional bending methods. We're seeing architectural elements that were once considered too complex or costly now becoming economically feasible. The finished profiles coming off this machine meet the most demanding architectural and structural standards. Whether it's curved beams for a modern stadium roof or decorative elements for a luxury hotel, the Abbend APK240 delivers the precision and consistency that modern construction demands. Here's raw power meeting precision. The 4RHS-20-260, a 4-roll plate bending machine that's all business when it comes to heavy-duty plate forming. This machine represents the perfect balance of capacity, precision, and efficiency in metal forming. The 20-260 designation tells you everything you need to know about this machine's capabilities. It can handle plates up to 20 millimeters thick and 2.6 meters wide. But don't let those numbers fool you. When you're talking about steel plate, that represents some serious tonnage and requires enormous bending forces. What you're seeing here is the signature 4-roll configuration that eliminates the flat ends common with 3-roll machines. All 4 rolls are independently controlled, allowing for precise pre-bending of plate ends and continuous rolling of perfect cylinders. The bottom roll acts as a support, while the top and side rolls work together to create consistent curvature. The hydraulic system on this machine is impressive, generating bending forces up to 400 tons per meter of plate width. That's enough force to bend the thickest plates this machine can handle, even in high-strength steels. The hydraulic controls are infinitely variable, allowing operators to fine-tune the bending force for different materials and thicknesses. Speed and efficiency are key features of the 4RHS design. Watch how quickly that plate moves through the machine while maintaining perfect curvature. The powered bottom roll eliminates the need for manual plate positioning, significantly reducing cycle times compared to older machine designs. We're finishing with the crown jewel of plate bending technology, the Heistler VRM High 42003730. This massive machine represents the absolute pinnacle of German engineering in plate forming equipment. The numbers in the model designation tell an impressive story. This machine can handle plates up to 42 millimeters thick and 3.73 meters wide. We're talking about steel plates that individual pieces can weigh over 10 tons, yet this machine shapes them with remarkable precision. What makes this Heistler machine special is its hybrid drive system, combining hydraulic power for the massive forces needed with electric precision for exact control. The result is a machine that can generate over 3,000 tons of bending force, while maintaining positioning accuracy measured in hundredths of millimeters. The 4-roll configuration here is perfected engineering. Watch how smoothly that massive steel plate moves through the machine. The synchronized movement of all 4 rolls creates consistent curvature without the plate distortion that can occur with less sophisticated equipment. Each roll is independently controlled and can be precisely positioned based on the material being processed. This machine is designed for the most demanding applications: pressure vessels for nuclear plants, massive storage tanks for chemical processing, and structural components for offshore platforms.